now.
Video only you at the
No, video me. Today we are going to talk about somatic sensation. So who can tell me what somatic sensation is? Yeah? We started it in our previous class. Hope you are aware. We started it in our previous class. I've taught one topic. Are you hearing me? I have taught one topic. I've taught one topic. So go and read up. Are you there?
Yes, sir.
And for today's quiz, I'm going to set question from. So who can tell me what? Please don't make noise. Who can tell me what somatic sensation is? Sit down, please. Sit down. Who can tell me what somatic sensation is all about? Can somebody tell me what is somatic sensation? Okay, what is somatosensory system? When I say somatosensory system, what am I talking about? Somebody should tell me now. When we talk about somatosensory system, we are talking about the sensory system that has to do with what? With what? Conscious perception of touch, conscious perception of pressure, conscious perception of proprioception, pain, and all that. Are you there? Pain, temperature, vibration. Are you there? Yes. When we talk about somatosensory system, we are talking about the system that has to do with conscious what? Perception of touch. Right? Pressure. Right?
Yes, sir.
Vibration. Right? What else? Pain, temperature. What about proprioception? And proprioception. And if you would agree with me, the somatosensory system is different, right? Or will I say it is in contradistinction with what is referred to as the what? Special senses. Are you there? There's a difference between somatosensory system and what? Or let me say somatic sensation and special what? Sensation. You know our special sensation, right? Vision, right? Audition, right? Taste. What else again? Smell. All those ones as what? Special what? Senses, right? They are different from somatic what? Sensation. Or the somatosensory what system. The somatosensory system has to do with what? Conscious perception of what? Pressure, touch, right? When we say touch, we're talking about what? Tactile what? Stimuli. Do you understand? What else? Proprioception. And what else? Pain, temperature, and all that. Are you there? Are you there? Yes, sir. All right. So now, we usually have three major types of somatic sensation, right? So who can tell me one? You, tell me one. Somatic sensation. I tell me why. Tell me why. All right, look. The first one is, are you there? The first one is what? Mechanoreceptive sensation, right? Which has to do with what? Touch, right? Or if you don't call it touch, you call it tactile what? Stimuli, right? And then what else? And what? Position senses. Position what? Sensation. When we talk about position sensation, what are we talking about? We are talking about proprioception. So we can call it proprioception. Why are you laughing? We can call it what? Proprio what? Perception. Right? All right. The second one is called what? The second one is called what? Nociceptive sensation. Nociceptive what? Sensation. This one has to do with what? It has to do with tissue damage. Right? Tissue what? Damage. Invariably, we are talking about pain. Right? We are talking about pain, which has to do with what? Tissue what? Damage. Then the third one is called what? Thermoreceptive what? Sensation. Right? This one has to do with what? Temperature. Cold and hot. Is it also? Right. Now we also have other types or other classification. Right? This one is the major classification of what? Somatosensitive what? Somatic what? Sensation. We have other classification of what? Somatic what? Sensation. Are you there? Who can tell me? Who can tell me the other types? God bless you. The first one is what? Exteroreceptive sensation. This one has to do with the external what? Environment. Right? Sensation that has to do with what? The external what? Environment. The second one is called what? Visceroreceptive sensation. Right? When we talk about visceroreceptive sensation, what are we talking about? We are talking about sensation that has to do with what? The viscera. That is the internal what? Organs. Right? The viscera. The third one is called what? Proprioceptive sensation. Right? This one has to do with what? The position of your body. Right? The conscious awareness of your position or the spatial orientation of your body. Do you understand? The ability to know where your legs are positioned, the ability to know where your hands are positioned, the ability to know the position of your ankles, your joints. Are you there? The position of your nose. If I close my eyes, right, I can tell you the position of my head. I know the position of my shoulders. I know the positions of my what? Senses. Are you there? Are you there? Then which other one do we have? Who can tell me? Which other one? Tell me now. We have deep sensation. Deep sensation. When we talk about deep sensation, what are we talking about? We are talking about sensation that has to do with what? Deep tissues. Right? Tissues like what? Your fascias. Is it fascias or fascias? Fascias, right? Or fascias. Right? Your bones. And all that. Are you there? Are you there? All right. So now, the way of the receptors that are responsible for mechanoreceptive what? Sensation. And the receptors that are also responsible for what? Proprioceptive what? Senses. Are you there? And then later on, we'll now talk about the receptors. We mentioned the receptors that are responsible for what? Nociception. Are you there? And then we'll now talk about the pathways. Are you there? We'll talk about what? The pathways. Now, when we talk about mechanoreceptive sensation, mechanoreceptive sensation has to do with what? Tactile what? Stimulation of touch. Are you there? It has to do what? Tactile what? Stimulation of what? Or what? Touch. Are you there? And then pressure is also there. Are you there? Pressure is there. Vibration is also there. And then perhaps proprioception. Are you there? Now there are certain receptors that are responsible for transmitting these what? These modalities of sensation. Right? These modalities. And what are those mechanoreceptive what? Receptors. Number one is what? I think I mentioned it in the last class. Number one is what? All right. The first one is called what? Fasciculus. One is called what? Fasciculus what? Corpuscle. Ending. If you don't call it peritracheal ending, what do you call it? We call it air ending. What do you call it? We call it air end organ. Are you there? We call it what? Air end organ. Then which other one? Raffinine ending. Are you there? Raffinine what? Ending. Now if you look at the skin is like this. Right? This one is called what? What do we call it? Tell me now. Stratum what? It is called stratum what? Corneal. Granulosum, we have stratum what? Granulosum, stratum what? Spinosum, and then stratum what? Basal. So this last one is called what? Stratum what? Basal. And they are attached to what we call naked what? Disc. Are you there? They are located. Right? Okay, sorry. This is responsible for what? Okay, sorry. This is responsible for what? This one. The naked disc is right. Your lips, right? Your lips. Your what? The tip of your what? Fingers. Your palm. Are you there? All right. Yeah. Of course, you should also know that this lemniscus corpuscle is a rapid adapting what? Receptor. We talked about this in our previous class. This one is a slow adapting what? Receptor. Right? So we have covered this. And then we have covered which one? Naked disc. Right. Then we also have what we call free net endings. They are located deep within the what? Within the skin, and also in the superficial part of what? The skin. Right? We call them what? Free nerve what? Ending. Right? And then we also have, now in the skin, right? You know, we have the epidermis, right? We have the dermis, and then what? Then we have what? The dermis, and then what? Hypodermis, right? Are you there? Yes. Now, deep within the dermis and the hypodermis, we have what we call what? The fascicular what? Corpuscle. They're like this. It has several concentric what? Laminas. Are you there? Are you there? Yes. And it is also a rapid adapting what? Receptor that is responsible for transmitting information that has to do with what? Pressure. And that is why it is located deep within the what? Skin. You know, when you touch the skin, you press the skin down, right? You feel what? Pressure. The fascicular corpuscles are responsible for transmitting that what? Information. Are you there? Then which other one again? We have the peri what? Strical what? Endings. Right? Now, if you look at the skin, we have what we call hair follicles, right? We have what we call what? Hair follicles. Now, in these hair follicles, we have the hairs, right? Now, beneath the hair follicles, at the base of the base of the hair follicle is entwined with some nerve what? Endings. Are you there? Now, these nerve endings call to, they bring to your notice whenever, let's say, a moving object is moving on your skin, right? They bring attention to that what's moving on object, because normally, if, for instance, a moving object is moving on your skin, right? It will what? Displace the hair on your skin. And when it displaces the hair of your skin, what will happen? It will what? Stimulate the what? The nerve that's entwined around the what? The base of the what? The hair follicle. Are you there? So we call that what? We call it the what? The hair end organ. If you don't call it hair end organ, we call it what? The peritracheal what? Ending. Are you there? Then we also have another one that is located in the dermis, right? But not the apical. You know, we have two. The dermis is divided into two. We have the apical region, and then we have the what? The reticular what? Region. Deep within the reticular region, this is the what? Apical what? Region. This is the reticular what? Area, right? Deep within the reticular area, there is a receptor that is responsible for what? Detecting what? Stretch. Stretch. Are you there? Stretch and touch. Stretch and touch. That receptor is called Ruffini what? Ending. Are you there? It is called what? Ruffini what? Ending. Are you there? Now, all these mechanoreceptors can also detect vibration. Are you there? They can also detect what? Vibration. You know, vibration has to do with what? A repetitive what? Stimulation of what? Nerve endings. When nerve endings are, sorry, when sensory receptors are stimulated repetitively, right? What they transmit is what? Vibratory what? Sensation. All these mechanoreceptors can actually transmit vibration, right? But the Fasciculus corpuscle has a tendency to transmit what? The high frequency what? Vibration of about what? 800 watts. 800 watts circuit per what? Per second. Are you there? And then the Fasciculus corpuscle has a tendency to transmit low frequency what? Vibration. And you can do that with other what? Other what? Receptors. Are you there? Are you there? They transmit what? The low frequency vibration of about what? 8 circles per second. Are you there? Are you there? Now let us talk about how this information, these impulses are transmitted. But before I talk about that, it is important to know that all these receptors transmit their, okay, I taught you about classification of nerve fibers, right? Did I teach you? Classification of what? Nerve fibers, right? And how do we classify nerve fibers? We have general classification, right? And then we have the alternative what? Or the sensory what? Classification. Now for the general classification, nerve fibers are classified up into what? A and what? Type A and what? A and C. Right? A is further divided to what? A alpha, A beta, A gamma, and A what? Delta. Right? Are you there? Now, A fibers are highly what? Myelinated. Right? A fibers are highly what? Myelinated. And in fact, the A alpha are very, very much what? They are highly myelinated, followed by what? A beta. Are you there? And then followed by what? A gamma, and then A what? A what? Delta. Are you there? So now, which class of nerve fibers does the meniscus corpuscle belong to? A beta. It belongs to what? A beta. What about Meckel's disc? A beta. Fascicular corpuscle? A beta. Are you there? A beta. Muscle spindles, where does it belong to? A alpha. Are you there? A alpha. What about Golgi tendon organs? A alpha. But you know that which mechanoreceptive information that are given at what? Who can tell you? Number one is what? The dorsal column-medial lemniscal system, and the second one is the anterolateral what? System. The anterolateral system is also known as what? It is also known as the spinothalamic what? System. Are you there? The anterolateral system is also known as what? The spinothalamic what? System. The first one is what? The dorsal column, medial what? Lemniscal system. Right? Or you call it DCML. The second one is called what? The anterior what? Lateral system. If you don't call it the anterolateral system, what do you call it? You call it the spinothalamic what? System or tract. Are you there? All these are known as ascending what? Tracts. Are you there? They are known as what? Ascending what? Tracts. You know what ascending tracts are? They are tracts that carries information from the spinal cord to what? To the brain. Are you there? What about descending tracts? Descending tracts are tracts that carries information from where? From the brain down to the what? Spinal cord. So the dorsal column-medial lemniscal system and the anterolateral system are known as what? Ascending what? Tracts. Are you there? So what is a tract? What is a tract? Who can tell me what a tract is? Have you heard of ganglia? You have heard of ganglia and you have heard of tract. So, okay, tell me what is a tract and what is a ganglia? And what is a nucleus? Three terms. Tract, ganglia, and nuclei. Tract, ganglia, and nuclei. What is a tract? What is a ganglia? And what is a nuclei? Should I tell you? All right. Now, when we talk about ganglia, right? We are talking about group of what? Neurons, neuronal cell bodies. Are you there? Group of neuronal cell bodies that are located outside the what? CNS. That is, they are located in the peripheral what? Nervous what? System. Are you there? A nuclei are a group of what? Neurons, right? They are located within the central nervous what? System. So when you talk about basal ganglia, that term is wrong. It is supposed to be called basal what? Nuclei. Why? Because it is located within the substance of the brain. It is located in the CNS. So it will be called basal what? Nuclei. Do you understand? Now, again, what is a tract? You know that nuclei usually have axons, right? And basically they move up together. Do you understand? Are you there? Now, if you look at the spinal cord, right? You look at the spinal cord. The spinal cord has gray matter and white matter. Is it not so? That gray matter is made up of what? It's a collection of what? Neuronal what? Cell what? Bodies. Are you there? Are you there? The white matter consists of what? A collection of what? Axons. Are you there? A collection of what? Axons. Right? So a tract is a collection of what? Axons that run across the CNS. Are you there? Are you there? It's a collection of what? Axons that goes up or down. Sorry? In this case, we are talking about ascending tracts, right? That goes up, what? The CNS or the spinal cord. You get it? Do you understand? Yes. Sorry? No, they are not myelinated. Are you there? They are not. All right. So, where are we now? Okay, we are talking about the dorsal what? Column-Medial Lemniscal what? Pathway. So let's talk about that one. The dorsal column-medial what? Lemniscal system. You know that there is a difference between the dorsal column-medial lemniscal system and the anterolateral system. You know there's a difference, right? So what is the difference? What's the difference? What? Information that has to do with what? A high perception of what? Pressure, right? The ability to judge pressure. You know, if I touch you, if I apply pressure, like a light pressure, I should be able to know that the pressure is light, right? If I add more force, I should be able to know that the force of the pressure, the intensity of the pressure has increased. What is responsible for that is the dorsal column-medial what? Lemniscal what? System. Are you there? Are you there? Yes. And like I said, it transmits information that has to do with what? A high degree of what? Temporal and spatial what? Localization and fidelity. But then the anterolateral system is not like this one. It is a primitive system that transmits information that has to do with crude touch, temperature, right? Temperature, pain, right? Pain, and perhaps sexual what? Arousal. Are you there? Sexual what? Arousal. Even each is transmitted by what? The anterolateral what? System. The advantage that the anterolateral system has over this one is that it can transmit a broad spectrum of sensory modalities. Are you there? It can transmit a broad spectrum of sensory what? Modalities. What do I mean by that? It can transmit more what? Sensation. You know what modality is? Modality of sensation. Pain is a modality. Touch is a modality. Right? Visual is a modality. Audition is a modality. Sexual stimulation. They are all different what? Modalities. Right? Anterolateral system can transmit a broader spectrum of what? Sensory modalities than the dorsal column-medial lemniscal system. This one can only transmit what? Tactile what? Stimuli, vibration and proprioception. Are you there? But anterolateral system can transmit pain. It can transmit temperature. It can transmit what? Pressure. It can transmit itch. It can transmit what? Sexual what? Stimulation. Do you understand? Are you there? So let us talk about each of them. Let's talk about them one after the other. Are you there? Now, I mentioned earlier on that there are receptors that are responsible for picking what? Tactile stimulation. Is it also touch? Right? Now let's say that let's say this one now. This is business what? Opposite to, right? This one, let's say this one is what? Merkel's Higgs. Which other one? Fasciculus. Air organ. I even free that ending. Free what? That ending, right? Now all these All these will send their zones. They will all send their zones down. Thank you. Where is this zone going to? Who can tell me? God bless you. It is going to the spinal cord. Are you there? It is going to where? The spinal cord. Now, this is our spinal cord. Right? Is it not so? Sorry. You know the spinal cord has what? What is this? What is this? Posterior what? Median what? Septum. Are you there? This is white matter. Are you there? But here, this one is called what? Dorsal column. Then we also have the anterior commission. Right? Now you should know that tracts usually run in the white matter. Is it also? Tracts usually run in what? In the white matter, not in the gray matter. Are you there? So we can have tracts here. We can have tracts here. We can have what tracts? Are you posterior roots, right? Has what we call what? Those are roots what? To form what? Is what? The spinal what? Trunk. Are you there? The spinal nerve what? Trunk. Are you there? Right? Eventually you know that they will divide to form the posterior rami and the what? Anterior what? Rami. Are you there? Are you there? Alright. So now, you know that this posterior root or the dorsal root contains what? Both. Are you there? They will go towards the dorsal what? Root. Are you there? Those are what? Roots. And we have what we call the pseudo-unipolar what? Neuron. Right? The pseudo-unipolar neuron has what? Two what? Two what? Processes. One ganglia. Are you there? The root ganglion that contains what? Other neuron, which is a unipolar what? Now the unipolar neuron has two processes. One is the neural process that brings information from where? From the receptors. Where receptors picks the information that coming from the lower extremities goes to where? Fasciculus what? Gracilis. Information that coming from the upper extremities and the upper trunk goes to where? Fasciculus what? Cuneatus. Do you get it? From yes, upper extremities, right, and upper trunk. They go to where? Fasciculus what? Cuneatus. And information that coming from the lower extremity goes upward. Are you there? Are you there? Now, let me do a smaller diagram so that I can draw something. Can you see? Information that coming from the lower extremity goes to where? Gracilis, fasciculus what? Gracilis. This one The one coming from the upper extremity goes to where? Cuneatus, right? And ascend upward. And then they go up to where? Where do they go to? Order what? Neuron. Second order neuron. Are you there? Now in the medulla, right? The second order neuron gives out fibers, right? That actually decussate. There is decussation of what? Fibers of the what? Second order what? Neurons. That is to say that this fiber, right? Do you understand it? Are you there? Do you understand it? Are you there? There is decussation of what? Fibers. Are you there? Do you understand it? All right. Now, if you look at this arrangement, you observe that for the dorsal column, there is a spatial orientation of the fibers. The fibers are arranged orderly. That is to say that fibers that are coming from below, fibers that are coming from below lies what? Medially. The fibers that are coming from the upper extremity lies what? Laterally. Are you there? Then when they get to the medulla, what will happen? It will cross. Are you there? And then the fibers that are coming from the lower extremity will now lie what? Laterally. And the fibers that are coming from the upper extremity will now lie what? Medially. And they will continue like that. And what do they continue as? They continue upward, right? They continue upward as what? The medial what? Lemniscus. They continue as the medial what? Lemniscus. And that is why we call it the dorsal column-medial lemniscal what? System. Are you there? They continue as what? The medial what? Lemniscus. Do you understand it? Now this crossing, right? These fibers that cross, right? Together. What do we call it? What do we call this fiber? We call it the internal aquate what? Fiber. This is called internal what? Aquate fibers.
Excuse me, please. If you have references in 200 level, histology and embryology, go downstairs and write your reference. I know so now you will talk. Go downstairs and write your reference before you finish. Histology, embryology, go downstairs. 200 level, go downstairs and write it now. Before we do it in class.
Please don't make noise. Don't make noise. This is there is internal aquate fiber. You should know that there is also external aquate fiber. Are you there?
Do you know?
Hello? If there is internal aquate fiber, there is also external what? Aquate fiber. Who can tell me about the external aquate fiber? Who can tell me? No cerebral, not cerebral. The external aquate fiber is going to the cerebellum. Are you there? It's going to where? The cerebellum. And it is coming from where? From the accessory what? Cuneatus nucleus. Accessory what? Cuneatus nucleus. From the accessory cuneatus nucleus, it passes through the what? The inferior cerebellar pedon cone and enters the cerebellum. And what does it do? It transmits information that has to do with proprioception. Are you there? Alright. So now what I'm interested in is this what? Medial lemniscus what? Fiber. Now where does this fiber go to? This fiber goes where? It goes, okay, let me draw it here. Hello? This is what? Don't make noise. Don't make noise. There is decussation. I want to get just see what accident when we enter here. This is 300 level. No, go to another one. Can we do the answer? Hello? Hello? So now look at. I told you that the fibers decussate, right? It crosses. There's crossing of the fibers. This one comes to this side. This one comes to this side, right? All right. So this is what? Medial what? Lemniscus. Medial lemniscus. Right? Now, this is what? Medulla. Right? This is what? What is this? Nucleus gracilis. Nucleus what? Cuneatus. This fiber is called what? This decussation is called what? Internal what? Internal aquate what? Fiber. Are you there? Now, you know what this is? This is called what? Thalamus. Are you there? It is called what? Thalamus. Then we also have another structure here. What do we call this structure? We call it the internal what? Capsule. Are you there? There's another one here. Right? Right. So what do we call this one? What do we call this one? No, we call it lenticular what? Nucleus. Are you there? This one is called what? Lenticular what? Nucleus. And it consists of what and what? The lenticular nucleus consists of what and what? It consists of the putamen and the globus pallidus. Are you there? It consists of what? The putamen and the globus what? Pallidus. Now, these fibers, the medial lemniscal fibers ascend upwards, right? And where do they go to? They go to what? The thalamus. Are you there? Where do they go to? They go to where? To the thalamus. Which part of the thalamus do they go to? Which part of the thalamus do they go to? No, not the internal capsule. No. They go to the VPL. Ventral posterolateral what? Nucleus. Are you there? You know the thalamus? Okay, let me draw something. Can I clean this? Can I clean this? The thalamus. Hello? The thalamus is divided into three, right? It is divided into three parts by what we call internal medullary what? Lamina. Are you there? Internal medullary what? Lamina divides the thalamus into three parts. This one is called what? Anterior part. This is what? Medial part. And this is what? The lateral what? Part. Are you there? In the what? Anterior part we have what we call the what? The anterior thalamic what? Nucleus. Anterior thalamic what? Nucleus. Right? The dorsal part we have what we call what? The dorsal-medial what? Nucleus. The lateral part is divided into two. Right? We have the what? The ventral part and the dorsal what? Part. In the ventral part is divided into the ventral anterior, right? And the ventral what? Lateral. Is it also? Then here, okay, no, sorry, three. Into three. Then ventral anterior, ventral what? Lateral, and then ventral what? Posterior. The ventral posterior is further divided into two, right? We have the VPL, and the VP what? M. Are you there? Are you there? Now, these fibers actually come to where? To the VPL. Are you there? So they come to the what? The VPL. They go to where? To the VPL, the ventral posterior lateral what? Nucleus. And that is where we have the third order what? Nucleus. In fact, the third order nucleus is the ventral posterolateral what? Nucleus of the thalamus. Are you there? Are you there? So we have our third order what? Third order what? Neuron. Here. That's where we have our third order neuron. Are you there? Now, from here, the fibers, right? From here, the fibers crosses the posterior limb of the internal capsule. Are you there? They cross the posterior limb of the internal what? You know the posterior limb, the internal capsule has three limbs. Sorry, three parts. We have anterior limb, posterior limb, and which other part? The genu, right? This is what? Anterior limb, posterior limb, and this is the what? Genu. Are you there? So these fibers, right? The fibers that are coming from where? From the VPL passes to the posterior limb of the internal what? Capsule. And that place is very, very significant. It's very important. Why? Because there are some blood vessels that actually supply that area. Are you there? And those blood vessels are called what? The striolenticular what? Arteries. The striolenticular arteries are branches of what? Of the middle cerebral what? Artery. So if anything happens to these arteries, the arteries that are supplying this area, what will happen? If these fibers here will have problem. Are you there? Are you there? If there is a lesion here, then the fibers will have problem. Are you there? And the individual will also have what? Problem. Are you there? Alright. So now from here, the fibers passes through the posterior limb of the internal capsule and then begins to fan out. They begin to fan out and go to what? The cerebral what? Cortex. Are you there? Right. So the fibers actually form a crown. Right? They form fibers that look like what? A crown. What do we call this structure? We call it what? We call it the corona radiata. Are you there? It is called what? The corona what? Radiata. So this is what? Corona what? Radiata. Are you there? This is corona radiata. This is internal what? Capsule. Right? This is the thalamus. This is the medial what? Lemniscus. Are you there? So now eventually these fibers terminate in a specific area of this cerebral cortex. Are you there? So which area of this cerebral cortex do they terminate? Yeah. Area what? Area 312. Are you there? Area 3, 1, 2. All right. If you look at the brain, right? There is a sulcus, right, that separates the frontal lobe from the parietal what? Lobe. What is that sulcus called? It is called the central what? Sulcus. Are you there? Now, posterior to this sulcus, there is a gyrus. Are you there? We call that gyrus what? We call it the postcentral what? Gyrus. Anterior to this sulcus, there is another gyrus, which is called the precentral what? Gyrus. Are you there? It is located in the posterior part of what? The frontal lobe. But this one is located in the anterior part of the parietal what? Lobe. This is called the postcentral what? Gyrus. Postcentral gyrus. Are you there? And this area is where we have the somatosensory what? Cortex. Are you there? The somatosensory what? Cortex. So we call it somatosensory area 1. We also have somatosensory area 2, which is actually behind this area. So this is SI1. Are you there? And this is what? SI what? SI2. So this is somatosensory cortex. Primary somatosensory cortex. This is what? Secondary somatosensory what? Cortex. The primary somatosensory cortex is responsible for what? What? It receives what? It's for perception of tactile what? Stimuli. Vibratory stimuli. Right? Are you there? Touch. Mechanical, mechanoreceptive what? Sensation. All those sensations are perceived what? Here. Are you there? And that is where these fibers eventually terminate. Are you there? Are you there? They eventually terminate where? In the postcentral what? Gyrus. Are you there? And you should know that there is a somatotopic map of the body in this area. Right? There is a somatotopic map of the body in this area. That is to say that there is an area that is responsible for perceiving what? Your lips, your tongue, your eye. If I stimulate certain areas here, right, your lips will be stimulated. If I stimulate certain areas here, right, your tongue will be stimulated. If I stimulate certain areas here, your genitals will be what? Stimulated. So it has a somatotopic representation of the entire what? Body. Do you get it? Are you there? And also, you should know that in the cortex consists of 6 layers. How many layers? The cortex consists of 6 what? Layers. It is called what? Molecular what? Layer. Layer 2 is called what? External granular layer. It is called external granular what? Layer. Layer 3 is called what? It is called external pyramidal layer, or the area of small pyramidal cells. Are you there? Area 3 is the area for what? Small pyramidal cells, or you call it external pyramidal what? Layer. Layer 4 is called what? Layer 4 is called what? This is called what? Molecular layer, external what? Granular layer, right? This is called external what? Pyramidal layer, right? This is called internal what? Granular layer. This is called internal pyramidal layer, right? Or if you don't call it internal pyramidal layer, you call it area of large pyramidal cells, because that is the area that we have the large kind of what? Pyramidal cells, which are called what? We call them what? The bed cell. We call them what? I think. Are they still writing the test? Are they still writing it? That call them. I'm coming, let me check. My phone is here, please.